Oh my God, one more period. 3/6/2020. All right, it is absolutely imperative that you have these memorized. Tangent of theta is?
Sine theta over cosine.
Good. Thank you for attaching thetas, because without the angle, it is meaningless. All right, cotangent of theta is? Cosine theta over sine theta. Very good. So those are good. Now, here are the really important ones. The Pythagorean identities. What's the big kahuna? Cosine squared theta plus 1. Very good. Cosine squared theta plus sine squared theta equals 1. Can you rearrange those for me?
Yeah.
Good. All right. Cosine squared theta equals 1 minus sine squared theta. That's good. Do you have to know that? No. If you know that one, can you do that?
Yes.
Yes. Okay. That's why this is called the big kahuna. All right. Sine squared theta is the same as 1 minus cosine squared theta. Very good. So subtracting the cosine term to the other side. Okay, good. What's our other Pythagorean identity? The second one. Cot plus 1 equals cosecant. All right, cosecant squared theta, cotangent squared theta. Cot plus 1 equals cosec. All right. Keep that in mind. That's a great saying. And again, you can rearrange these things. So cotangent squared theta is equal to what? Cosecant squared theta minus 1. Good, good, good. What's 1 equal to? Cotangent squared. Good, good, good. So if you get the 1 by itself, you just have to subtract the cotangent to the other side. Okay, and again, these are the ones that I care about. These are how we use them. The other fun saying I had for you, 1 adds a tan by the secant squared theta, tangent squared theta. Okay. All right, very good, very good. 1 adds a tan by the C. Adds a tan. 1 adds a tan by the C.
I just get sunburned.
All right. Very good. So those are definitely the identities we need to know, including the reciprocal identities. And we are learning some more techniques for simplifying today as well.
Is notes going to be long today?
Not too bad. Okay. All right. All this in this unit is quite manageable, but it requires practice. All right, example 1. Use the fundamental identities to establish the identity. You're going to see some phrasing called establishing the identity or verifying identities. And what that means is you're trying to show, they're telling us, hey, these two things are equal. And the math teacher's favorite phrase, but why? Okay, your job is the but why part. So what we're going to do is we're going to take usually the more complicated side. We're going to take the more complicated side and try to shrink Rubik's Cube it back together the right way, okay? And so we're going to start usually on the more complicated side and try and clean it up so that we get down so that that left-hand side is identical to the right-hand side, okay? Checking for balance. We want to prove that these two things are in fact equal. Now, we could do it graphically. You could type this into your calculator and see that they are graphically equal. The left side is graphically the same as the right side, okay? These two, cotangent t times cosine. That's a good question. They are right next to each other. That is a product. All right. So one method that we have is to rewrite using sine or I guess I should say and cosine. So rewrite using sine and cosine. I'm only going to rewrite using sine and cosine when I have a plethora of trig functions. All right, and I just got the three amigos in my head just now. Did you catch that? A plethora. You know that, see, what is it? I can't remember now.
It's
Would you say I have a plethora of?
Is that?
No, but it's from Three Amigos.
Yeah.
Okay. Okay.
You just.
I haven't seen Hotel Transylvania, so I don't. Okay. All right. So when I look at this, one thing that I can do is I see that I have a sine function, I have a cotangent, I have cosine, I have cosecant, I have 4 different trig functions, and because I have 4, I'm going to go ahead and I'm going to do this. I'm going to change them so that I only have sine and cosine. So let's see what happens. Do I need to change sine of t?
No.
No. How are we going to change cotangent of t?
Cosine over sine.
Cosine t over sine t, whatever your variable be. Okay. Times, do I have to change cosine? No, leave that alone. But I do want to change this side as well. Cosecant can be
1 over sine.
1 over sine. So this is okay. Now, everything is in terms of sine and cosine. Now, I do not touch this other side. I'm going to just work one side. Work only one side of the equal sign. All right. The only thing you're allowed to do is maybe rewrite it using sine and cosine. Tighten it up a tiny bit. That's it. We don't want to do too much. We just want to work one side. What happens over here on the left? Do they cancel? No, they don't. Okay. So we get sine of t plus, what does this become? Cosine squared t. Very good. Over sine of t. Okay. Good. And then, what do we need to do to add fractions together? Common denominator. So I'm going to multiply my first fraction by sine t, top and bottom, which gives me a common denominator of sine of t. Good. And what is my new numerator now?
Sine squared
Plus cosine squared t. Ding, 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 ding. Ding, 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 ding. Bells are going off. Bells are ringing. Because it's an identity. What is sine squared plus cosine squared? 1. That is our Pythagorean identity. Sine squared plus cosine squared is 1. So trade that out for that 1. Much easier. Over sine t and ding, 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 ding. We're done. Look at that. We did it. Yay. That's it.
So you're just confirming it.
You're confirming what we already knew. Yes. That's very, yes. Yes. But these are all going to be true. Okay. Yeah. That's what can fit. Yeah.
It's still an example.
No. No, there's more. Oh, there's more. Okay. Questions on this one? That was pretty fun, right? You're like, oh, look at that. It's magic. All right. Couple more. Now, what you need to remember is these are not equations. Our job is to work one side to prove that it is the same as the other side. And so don't rearrange things. We have sine of x times cosine squared of x minus sine of x. And it's supposed to be the same as negative sine cubed of x, which is kind of interesting. So example 2, factor. We have lots of ways to factor. you need to remember that there's this thing called the greatest common factor. We always, always, always look for the GCF first. Really important. If there is no GCF, then perhaps we can double bubble. You can factor just like we could before. Now, first of all, do I need to rewrite using sine and cosine? No, because they're already using sine and cosine, right? All right, so I am just trying to prove that we're equal to this nice cleaned up side here. So we need to work this left-hand side. What can we do on that left-hand side? Undistribute the sign of x. They two terms. You see they both have the sign of x? They both have the sign of x. If I factor out the sign of x, what's left behind? Square root of x minus 1. Very good. If you were to distribute sine of x times cosine squared, you'd get sine x cosine squared. Sine of x times negative 1, you'd get negative sine of x. So we're undistributing. All right, and I heard a ding, 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 ding. Ding, 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 ding. Now careful, that's a whoop, whoop, whoop bell instead. Because there, what is cosine squared x minus 1? Negative sine squared x. All right, why? What's our identity? Cosine squared theta plus sine squared theta equals 1. We have cosine minus 1. So cosine squared theta minus 1 means that I'd have to move this term to the other side. So that's why it becomes negative sine squared of x in this case. Sure.
In your second step, how did cosine of x squared stay the same, but then negative sine of x turned into negative 1?
If you were to distribute sine of x times cosine squared gives you sine cosine squared, and sine times negative 1 is negative sine. Yep. All right, so be careful. Cosine squared of x minus 1 is not the right order. That gives us a negative sine squared times that sine of x out in front. What is sine of x times sine squared of x? Negative sine cubed of x. And ding, 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 ding. We did it. Good? There's no like, oh, yay. Oh,
Yeah, there
okay.
Never mind. I was gonna ask why is it
Two sine squares of x?
Yeah,
Yeah,
and
yeah.
then I realized
They're multiplied, yeah. So this is like x times x squared, which would be x cubed. Sine to the first of x times sine to the second of x is sine to the third of x.
Is it right for me to assume that you're gonna give us an example which does not equal the answer?
No,
They should all equal.
they should all work.
Oh, that's
Yeah.
perfect.
Yeah. So you have the solution. You have the answer. We just need to prove why. Yeah.
So we're definitely in solution.
Yes. Yes, exactly. Work is the important part. All right, letter B. Letter B. How many terms do I have on that left-hand side? 3 terms. 3 terms on that left-hand side. Very good. And look how boxed up that comes too. That's cool. All right. That's the reverse Pandora's box. That's kind of cool. All right. Is there a GCF? No, but there are 3 terms. And so I can double bubble. What times what is 1? 1 times 1. What times what is cosine to the 4th?
cosine is
Cosine squared x and cosine squared of x would be cosine to the fourth of x. How do we make it negative? Negative cosine. Negative cosine squared of x times negative cosine squared of x would give us that positive. How do we get that middle term? The rainbow. Yeah, that rainbow. So negative cosine squared and a negative cosine squared gives us that negative 2. Okay, very, very good. I hear the bell. Okay. Okay. Ding, 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 ding. What is sine squared of x? All right. Times. What is ding, 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 ding?
Oh, sine squared.
Another sine squared of x.
I think you're gonna have to make that.
And then you multiply them, and that gives you sine to the fourth of x, which ding, 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 ding. Oh my goodness, we're done. Is that pretty good?
You know that's all you're gonna get in the test,
Ding,
right?
ding, ding, ding. Okay. Are you good with that? We got one more. Okay. I do think that this was one of the problems on yesterday's worksheet. Or did we do this one yesterday? Did we do this in notes? Did we do this in notes? No? Okay. This one. Did we do this yesterday? No. Okay. All right. Example 3. Perform the addition and subtraction, then simplify. All right. Perform the addition and subtraction, and then simplify. We have tangent of theta plus cosine theta over 1 plus sine theta, and it's supposed to equal secant of theta. What do you think we should do first? Change tangent, okay. What would you like to change tangent into?
Sine theta.
Good. Sine theta over cosine theta. Very, very good. Plus cosine theta over 1 plus sine theta. Excellent. Now we are adding fractions. What must you have to add fractions? Common denominators. So what should I multiply this first fraction by? 1 plus sine theta on top and bottom. And I really encourage you to actually write it in. Don't be lazy, because when you're lazy, mistakes happen. For instance, not realizing that this is multiplying. What do you need to multiply the second fraction by? Cosine theta on top and bottom. So really, smush it in there. No, smush it. I really try to make this interesting for myself, because this is like, I don't know, the 35,000th time I've done this. All right. Now, we have a lovely, lovely common denominator. That common denominator is 1 plus sine of theta times cosine of theta, however order you say it in. I am going to leave it factored most of the time, because I'm hoping things will cancel. Now, in the numerators, what happens with this first numerator? You have to, the numerators, you do have to multiply. So you do need to distribute in your numerator. What do you get when you distribute in your numerator? Good. Sine theta plus sine squared theta. Good. Giant plus sine. And cosine times cosine is? Cosine squared theta. Da-ding, ding, 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 ding. Do you see it? Da-ding, 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 ding. Sine squared theta plus cosine squared theta is 1. That is our Pythagorean identity. And so we have a sine of theta plus 1 over cosine of theta times 1 plus sine of theta. It cancels out. What cancels out?
The sine theta and the 1.
Yes, this whole factor cancels out. Top and bottom, it reduces. And we get 1 over cosine of theta, which is secant of theta. Yay! Okay. Was that all right? All right. Be careful when you're multiplying. Do you have any questions for me? All right. Righteous. You guys have CP 37.